it later. So 44, a parabola has a vertex of 2, 5 and 2 x-intercepts, one of which is negative 5, 0. Okay? So there's something going on there. Let's plot that. Normally, you will not necessarily have something to plot it, but we will now. That's why I provided this to kind of give you a visual. So the vertex is 2, 5. So that's 2, 5 right here. That's the vertex. There are 2 x-intercepts. One is negative 5, 0. So negative 5, 0 is right here, correct? Which way is this pointing now that we look at this information? Down, right? So we know that this is happening here. And if this is the vertex, it's going to go through here somewhere, but we just don't know where. Let's label these points. Negative 5, 0. This is 2, 5. How could we find the other x-intercept here, or the other point? Remember I told you that any point along one of the legs, right, has one that's like right across from it on the other side. Would that make sense? Because it's symmetric. Okay, so here's where I'm gonna, if you did the homework, you may have seen this one. When we're talking about the axis of symmetry, right, that is an equation. And it's normally x is equal to, what would it be in this particular case? It would be 2, right? It would be that line that cuts it in half. Correct? But if you don't, if you're missing one of the points, you want to be using this. x1 plus x2. So you'll add up 2 x values and you divide it in half. Okay? So this is very much study sheet material right here. So what is that saying? Listen carefully here. Don't worry so much about the AC right now. Just make sure you pay attention to this, okay? It's basically saying if you have, let's make a little sketch here just for you. Okay? You can pick any 2 points that are right across from each other. And this would be your x1. And this would be your x2. So we're only worrying about the x values, right? This would be your x, okay, where the vertex is. So when you add up x1 and x2, okay, if you add these two up and you divide it in half, you're effectively finding the midway point between those two, okay? So x1, if you add these up and you divide it by 2, you will find that middle point between them. Okay, you're finding the average distance between these two. So you're finding that middle point. How's that beneficial? Well, watch this. I'm going to use a red pen for this. This is going to be my x1. Okay. This is going to be x, so the x value of the vertex is always x. This is x1. And the one that's out here, I'm not going to label it yet. Maybe we'll just do that out here. x2 is going to be somewhere over here. Okay. So what you do is this. You use this formula. What is x in this case? It's 2, correct? So we'll substitute that in. What is x1? Negative 5. Plus, do we know what x2 is? No, that's what we're about to find out. All of that divided by 2. And now you do some algebra. Okay. What would be the first? So our goal is to isolate x2. So the first thing is, let's get rid of this 2 dividing. So multiply both sides by 2. So that cancels out this, cancels out that. We're left with 4 on this side. and on the other side it's negative 5 plus x2. What do we do now? Add 5 to both sides, right? Or bring the 5 over, whatever works for you. So x2 is equal to 9. Okay. What does that mean? Okay. It means that if this is negative 5, then where are we out here? We are at 9 positive. Okay, so you just found that x-intercept here, which is across the first one. So now you have a better picture of what's happening. Okay. Do you have 3 points now? Yes. Can you do a regression? Yes. All right. So we have negative 5, 0. We have 2, 5. And we have 9 what? 0, right? Because, why do we know it's 0? Because we are going by this x-intercept. So we're going at the same height, right? We're going along there just across the pond. Listen carefully. If I had given you, let's say, negative 5, 2, right? Or, sorry, negative 2, 3, let's say, or something like that here, then you would have been finding the point across at that height. Okay, so you're always finding the point across the same height than what you started with. So this would be 9 what? 9, 0, right? So you go L1, L2, and we're going to do a quadratic regression. So if you need a refresher on how to do this, this is how you do it. Okay, stat, edit, negative 5, 2, 9, 0, 5, 0. Reminder, okay? Let's go back to word problems real quick here. If I gave you, look up here for a second, if I gave you the equation, would you have plot 1 turned on? No. Okay, if you're typing in an equation manually, turn off plot 1, because sometimes there's a conflict. But right now we don't have any equation, we're trying to come up with it. So I want to clear whatever is in the y's, make sure plot 1 is turned on. Then I'm going to do a zoom 9. And I can see my points are in the right place. Okay, it makes sense. So let's do a regression. Stat, calculate, quadratic regression, second 1, comma, second 2, comma, alpha trace. There it is. That's what you want to see. Run it. So that is our equation here. Y is equal to negative 0.10 x squared plus 0.41x plus 4.59. Okay. And you can hit graph, and here is the actual curve that models the scenario, right? So that's what you want to see. All right? So this concept, I'm going to bring this back a little later, okay? But if you're ever stuck, you can use this this formula here. If you have the vertex, let's say, and one other point, use this to find the second one. Okay, sorry, the third point in a sense, but the point right across from the one you are given. Let's go to 46. So I'm just jumping around, and I posted the key 46, this one right here. So I give you one point, I give you another point, but you don't know this exactly, correct? Don't guess, because there's a way to know exactly if you have points. Okay? Could I use my axis of symmetry formula that we just talked about? Yes. So what do you do? This is x. This is x1. What about x2? Can I call this x2? Sure. Then you just make that one x1. So this is x2 right here. We don't know what x2 is. We just know that the y variable is going to be 0. So you can find this point right there. It's a little tight here, but I will show you how I do it right here. So this is, I'm using this equation again. This idea. Okay. Vertex is 3. X1 is 4.633. Use all decimals if you have to. And then you divide it by 2. Guess what the first step is going to be every single time? It's always divided by 2, right? So you're going to have to multiply by 2. Cancel, cancel. Can you see that all right there? It's a little crowded, I know that. 6 is equal to 4.633 plus x2. We subtract. Okay, subtract both sides, and x is equal to, should have had my key on that page, right? I got it. 1.367. So now you know that this point over here, right, the x value of this point right here is 1.367. So we're going to figure out the equation here. Okay. X and y. Let me just bring this down a bit so you can see it. So the first one is 1.3670, then it's 3.4, and then it's 4.633 is back to 0. Okay, and these are your 3 points. You enter that, you come up with the equation, which I posted. Okay, I posted the key to that. One more thing I want to talk about here is you have to be careful. You should be able to observe this on your, in this case I gave you a graph, correct guys? I gave you a graph. Let's investigate. Here, this is the vertex, correct? The axis of symmetry would cut it right here. Looking at the x values, okay? From 3 to 4.633, how much did we travel here from the middle to this point? Mental math. 1.633, right? So how much is it going to be from the center back to this point? It's not a trick question, to be honest. This is just, it's going to be 1.633 as well. Okay, guys, that's always, because the vertex tells you where the middle is. So if it takes you this much to get to that side, it'll take you the same amount to get to this side. If that's what you prefer to do, you may do that, okay? So how would you have used this concept to come up with that point? We go to 3, right? And we subtract the 1.633 to get us here. You would get the same answer as I did. Okay, so if this is not something, I will at times ask you to use it, but if you need a different way to come up with the third point using the symmetry of the parabola, you may do so. Okay. Any questions for me? Don't look so sad, guys. It's okay. It's just math. It's not the end of the world. It's just math. And if it's a little bit too much, we'll do more, okay? We'll do more, and then you'll probably get a good grip on it.